When you make a comparison between two objects, it's easy to identify which one is bigger. However, the question, how much bigger, is a little ambiguous since there are many ways to talk about the size of an object. If we are going to use any of these measures of size, let's start by making an assumption. Let's assume these two objects have the same shape. We would say the two objects are isometric. This is helpful because if we said box Y is 2 times as wide as box X, then we know that the same is automatically true of the length and the height. So how do volumes of the two boxes compare? Well, the volume of a box is length times width times height, but notice that for box Y we can express the volume in terms of the volume of box X. We would then say that the volume of box Y is 8 times greater than that of box X. This is actually quite a general result. If we compare two spheres, where the radius of the larger sphere is 2 times the radius of the smaller, we will get the same result. The volume of the larger sphere is 8 times greater. Regardless of the specific details of the shape, if we double every linear dimension by a factor of 2, the volume will be 8 times greater. This is because any volume will always be expressed as the product of 3 lengths, radius cubed for the sphere, or length width height for a box. So when comparing two isometric shapes, we say that the volume is proportional to some representative length to the third power. Let's take a quick look at area. You've probably already encountered the formula for surface area of a box or a sphere. When it comes to calculating an area, we have the product of 2 lengths. This is true if we consider the cross-sectional area of an object as well. So when we are asked to compare the area of two isometric objects, we don't have to know the exact formula for an area calculation. Because area is proportional to a length squared, when we compare their areas, we can simply look at the ratio of lengths squared.